In this video, we will look at the virtual reality application I developed for my master thesis project. The goal of the project was to look at how virtual reality can be used as a tool for learning in artificial intelligence education. As a topic within AI, I have focused on giving an introduction to deep learning and neural networks. The concept of the application was to introduce escape room elements to make learning engaging. The idea is that the user finds himself in a virtual memory palace where the topics have been split into separate rooms. The user needs to solve puzzles and quizzes for each topic to progress through the rooms. I developed the application for the Oculus Quest, since this is a fully standalone device that requires very little effort to set up. The benefit of this is that the application can easily be made accessible for many students for a fairly low price compared to other VR headsets. Before we look at the deep learning intro, we can take a look at the tutorial. Since many users in the target audience are completely new to VR, they need to go through a tutorial that teaches every interaction needed to use the application. Currently, the application only covers deep learning intro. The idea is that in the future, users should be able to choose other topics within AI from the menu. The deep learning introduction goes through the topics neurons, cost functions, gradient descent, and backpropagation sequentially. The topic of neurons was split into two rooms. This gives the user an increasing difficulty through the topic. First, the user learns how the perceptron works, which is the simplest type of neuron. In each room, panels with information provide the user with the necessary information to solve the task. The first task is to make the neuron output equal to 1. This is done by placing inputs on the neuron. The user needs to understand how the weighted sum is calculated to complete the task. In the next room, the task is to calculate the output of a sigmoid neuron. Since this is a complex task for mental arithmetic, an activation function calculator is found in the room. The code is then used to open the next door. When the user has completed a topic, he finds a cartridge loaded with a quiz. The user needs to win each of these quizzes by having 80% correct answers. To make the application feel more rewarding, the user needs to collect each of the completed cartridges and place them in the bookshelf. As we will see in the end, the user completes the application when this is done. I didn't have time to create a meaningful visualization of the cost functions, even though I planned to do so. Therefore, the user can take the cartridge when he has studied the theory. For gradient descent, a visualization of some cost function with two-dimensional inputs was implemented. The visualization shows the execution of the algorithm and leaves a trajectory of where the ball has been. What you see here is just based on gravity, but the visualization still reflects how a local or global minimum is found by taking small steps in the direction of the negative gradient. Currently, the visualization initializes the ball at 5 different points. It was also considered to let the user place the ball and adjust step size. When the user has completed the gradient descent cartridge, he can progress to the last topic of the application, backpropagation. First, the user learns neural network notation by placing neurons in a neural network. Then, the user is given an overview of how a change in some weight affects the rest of the network with a visualization. After that, the user is given a task for understanding how the elements of the chain rule are related. The user can use the information on the wall. Then, an annotation task teaches how the chain rule is applied to find the partial derivatives in a one-layered network. In the end, error is introduced and the user is given a visualization of how the chain rule is used to find partial derivatives in a two-layered network. When the user has found the last cartridge, he can complete it and reach the final room of the application. I had a few more plans that I didn't have time to finish. The first of them was to create an open-ended puzzle in the end where the user can put together everything he learned. Secondly, the high amount of text used in the application was not optimal, but learning materials were time-consuming to create. To utilize the VR technology, more audio, video and 3D visualizations should be added. The Oculus Quest has weaker hardware compared to other VR headsets. Therefore, I ran into some performance issues that would be crucial to fix in order to use this application as course material.